So now that we've talked about strengths of acids and bases, we need some type of scale or a way to represent the solution activity. And the pH scale is this convenient way to represent the acidity of a solution. And we're going to define pH as the negative log of the H plus concentration. And we use a logarithm here because typically we have very, very, very small concentrations of either H plus or OH minus. So if our H plus concentration is 1.0 times 10 to the minus 7, then our pH is going to equal 7. Okay. In addition to representing the pH, we can also say something called the pOH, which is our negative log of our OH minus concentration. Okay? We can also use something called a pKa, which is going to be our negative log of the Ka. So anytime you see a lowercase p in front of something, it means we're taking the negative log of that. So if we look at some various H plus concentrations and we looked at the pH, for example, we have 1 times 10 to the minus 1, 1 times 10 to the minus 2, 1 times 10 to the minus 3, and 1 times 10 to the minus 7. The pHs of each of these are going to be 1, 2, 3, and 7 respectively, because we would take the negative log of that. And as we can see here, the lower the pH, the higher the H plus concentration in solution. So we can measure the pH using something called a pH meter, which is a very common instrument that you're going to be using in lab. So let's kind of look at our H plus concentration, our pH, and then what significance we would have for some of those. So here if we have 1 times 10 to the minus 14, 1 times 10 to the minus 7, 1 times 10 to the minus 3, and then 1. So our pHs here, if we have a pH of 14, that's kind of what we would expect for a 1 molar sodium hydroxide solution. And if we look down here at a pH of 12, that's going to be kind of sometimes what we would look at for our weak bases, like an ammonia solution. If we have a pH of 7, okay, we can look at various liquids like blood or maybe milk. They're not going to be exactly equal, but they're going to be very, very close to 7. A pH of around 3 would be something like vinegar, which is acetic acid. A pH of 2 is what our stomach acid would have a pH of. And if our H plus concentration is 1, the pH is going to be 0. So this kind of gives kind of a baseline of where the pH scale is and how we're going to look at these things. So we're going to do many calculations involving pH, and the key thing here is that whenever you see a lowercase p in front of something, such as the pH, it's going to be the negative log of the H plus concentration. The pOH is going to be the negative log of the OH minus concentration, and the pKa is going to be the negative log of the Ka. And we're going to be using all three of these equations throughout the rest of this section to determine various concentrations and acid-base strength, and it's going to serve us a wide variety of purposes to use these particular quantities.